Hello and welcome back. Sorry for the delay. I was making sure that everything was going out well, so I plotted ahead a bit, as every good programmer should. And I realized there was a couple of mistakes I've made. For one, this should not be a struct. It should be a class. The reason for that is because structs cause some interference later on in the project, whereas classes do as they're told. I also realized that you can take these enums and simply set them outside rather than inside the class to shorten some of the lengths. I don't believe we need this anymore either, since we have this. So get all keys, get the player's current state, mod variables, which we don't need, so I'm going to close out that. Input handler, updatable walking handler. Let's see. Switch main controller current state. Let's see. Over here in the player controller, input handler. So we'll have a private player info struct, which is no longer appropriately named because it's no longer a struct. It should simply be player variables or something akin to that. But we can atone for it right here instead. Sort of. Not really. Let's see. Public. We're making this public because we want to do what we did up here. The variables, typically, we're always going to be getting them, and curse you helicopter. So we'll go into the awake statement, say player variables equals new player struct, and let's see, actually no. So we don't actually do this, we serialize it instead, which means we can't have this nice clean function, we have to private it right here. Then serialize it. Wait. I'm blind, it seems. Yes, I'm very blind right now. Player info struct. Get variables. Return variables. And then we come over here to the input handler and get variables dot current state. And I do not believe we need this anymore. Well, technically we do, we just don't need this part of it. We can just say something like this. See, very simple. Very simple until you realize, whoops, we forgot to do a new name thing for this. I'm eventually just going to go back and put in namespaces for everything off camera, because on camera would be quite tedious. Let's see, getting all inputs, walking forward. So with this, I shall show you how I usually do walking. It's not updating. Alright, there we go. So with player walking, typically what I like to do is everything essentially walks the same. Which means that whenever an NPC walks uphill, they're either using a nav mesh to do it. Nav meshes are fine and typically how you should because they're quite powerful. Unless, of course, you want to make your own things, in which case I am not competent enough to know how to make my own things just yet. So far I just rely on nav meshes. However, to prevent if you want the enemies to be walking uphill at sort of not adjusting for their angles, or everything inside the scene is flat and doesn't, or is a 90-degree angle with the is parallel with the horizon, then that's fine. But I don't. So what I like to do is I like to make a walking handler, which typically states how a thing walks. Let's see, a walking function. Because it's not necessarily a handler per se, because we're not necessarily handling anything. It's more of a how-to. Like with a function for calculus or with algebra, where you plug in something and you get something out. It's like fx equals x to the power of 2. You would plug in x, which in this case would be 2, and you get 4 out. So with this one, since not all things walk the same, we might just have to say, how do we want them to interact with the ground? And with this, what we're going to do is we're going to input a levelly algorithm, per se, that essentially aligns a player with the ground. And then it returns the angle at which they walk. Now, you can return the angle at which they will walk, or, well, no. With the regular NPC, if you want them to be, I'll probably input a picture at this point. So they're facing the normal at which the ground is facing. Then you can return the normal. However, actually, I think this is mainly for the player. Or it can still be a walking function, it just needs to be static now. So let's say public static walk, or it needs to be a vector 3, because this is a 3-dimensional game. Even if it was a 2-dimensional, you'd still want to use vector 3 because that extra axis is helpful from time to time. Get, oh my god, get ground normal. This is actually probably a very horrible name. Get ground normal. Get ground. Yeah, that's very good name scheming. Let's see. So with this one, we'll essentially say if physics dot. Typically for this one, you would want to raycast because it can return a direct point. Whereas if it wasn't a direct point, then, well, a sphere cast or a what is it called? Sphere cast capsule, something like this. They're good and all, except they can also return the incorrect points. which leads it to being like, oh dear, what's happening? So with this one, we'll want essentially a transform. We'll also want a vector. Well, we don't necessarily want to do vector 3 because everything's going to be pointing to the ground. So that means we do transform dot position. Let's see, we're wanting to use 14 actually? No, not 14. So we're going to want to use 12 because it has the direction, origin, the out, and the max float distance. So with this one, we're going to do vector 3 dot down, out, ground, and the final one, I believe it was distance. We also want a layer mask. Wait, no. Yeah, wait. 15 has the layer mask as well. Okay. So the max distance, essentially, if you're at an angle, you want to get extra or more. For here, we're going to go in here and say, okay, we want the layer mask, mask. Then we also want a length or a float called length, which defaults to 2. Meaning if we go in, we can say, okay, the mask is provided here, say mask, and then we can do length. And it So I went over and checked out another thing. I got a simple equation. And we're going to have to use a cross product, which I typically do not like, but whatever. It's very fine and dandy. So one other thing that I forgot to add to this, because most likely we're going to have to choose which direction we're going in. So we're just going to do direction. This is essentially just me taking, vector 3, current walking equals direction, and we're going to be returning walking. Current walking. However, current walking will also equal the vector 3 dot cross product. Cross products are tricky, per se. Really tricky, in fact. I still don't know fully what they do. I believe it gets, you have 2 lines, and this one just sort of gets to the line that's in between. It's interesting. Now, you want to get the right of where you're going, and this is one of the reasons why I have no idea why. Right. So essentially, when you're going forward, you'll get to the right of the character. When your character is going backward, you'll get the you'll get the inverse of right, which is you'll be the left of the character. Oh, yes. The existence of everything dissuades my function. So you'll get right, and then ground dot normal. So essentially we're changing this up so that way whenever the character is walking up at an angle, it adjusts it so they don't walk into the ground. This isn't such a big problem until you realize that the character controller, the angle at which it goes up at, sucks. And it's better off to just adjust. So this is one way to do it. We'll go into input handler, or no, not input handler. We want to get the actual walking. So with input forward, we'll get rid of input forward actually, because we're gonna be getting a lot of walking, sort of. Well, yes, actually. With this, we'll just say public. Right, no, we want this to be private void walking direction. With this, we already have the transform of the main character, which, if I look at the actual thing, yeah, we're using it once. We could make this a vector 3 to transfer less information. So instead of transforming or getting all the transform, we're just getting the position of it. So let's say position. Backspace a little bit. Paste. Now we have the position, direction, and right. We have the layer mask, so we're not always getting the wrong thing. Or yeah, we only want to get the ground. Using a layer mask will assist us in getting only the ground. So now we have the position, we have the direction, right. The only one that stays consistent throughout all of that, well, the two, in fact, is the layer mask and the length. All the other ones somehow change, meaning, well, no, the position stays the same as well, but we'll need two vectors. Oh, we're not using Unity. This thing. Unity engine. We'll need the direction and vector 3 and the right. It's main dot controller dot move. From here we can say, well, since we get a thing from the walking function, and then we can simply times this by speed. But in this we'll need the position, which is main controller dot. Did we set it up to get the player as well? No, we didn't. Dot transform. So with this one, we can also set up a function in the player controller to get the game object, which I don't believe we did. We didn't. So do public game object. Well, we can also, truthfully, there's no reason to get the game object. We can just do the transform form. The transform will contain all the necessary variables we need. Body. Get private set. Then we'll go back over to the walking handler and say main controller dot body dot position. Why are you screaming at us? Using system. Wait. That's not right. Interesting. Oh. My mistake. Yeah. Just. It's late at night. Right. Layer mask. I believe that's in the player's player info. No, it's not. Okay. Let's see. Private layer mask. Ground layers. we'll also want to serialize this. Nope, not serializable. Serialized field. And then we'll do public layer mask, get ground layers. Return ground layers. Now with this, we go over to the walking handler and do main controller dot variables dot get ground layers. And then the float, I believe, actually I have no idea. We'll just leave that for now. Then in here we can say, well, there's one also other crucial detail. Input key. If input dot get key this is a key code, not an input. And then we can transfer it over. It's quite the long thing, and typically someone would do something akin to maybe this, where they slide it down. Now that's really only to make things look pretty. I generally don't do it because I wasn't taught like that, and I prefer to just drag this and scroll over. But I'm also not the most organized. Let's see. Walking direction. Let's see. I'll come back when I have this all set up. Alright, I have set up everything clean and simple. Now, generally this will, well, it'll work all the time. Hopefully. Whoops. I believe I forgot a negative on this. So what I did is I went into the player struct, added a bit more thing, got rid of the 0 because it's redundant. Let's see. There isn't much else to comment about this. Walking handler, input general, and the player controller. Now if I come into here, wait for everything to load. We can see on here all the keys. Now, the one bad thing about enums, well, the way we're handling it, is we'll have to assign the keys, or we'll have to know exactly which keys we're using. Like with A's. Then there's an S. Current state, crouch, standing, ground layers. For the sake of this, we'll just do everything. Actually, no, we don't want to do the default layer, because if we do the default layer, then we'll be getting our own character, which sucks. Let's see, ground. We can go back over here, do ground. Say, okay, ground layers is nothing, trace it, and then just do ground. Now, we haven't actually tested this in a while. Let's see if something breaks. And it did. Oh yes, that's because I forgot to reference it. Oops. The body needs to be set upon awake. Equals transform. Wait for it to compile. Yes, okay. Oh dear, wow. So this is in game. How about if we turn this up at a rotation of 45-degree angle? Ah, see? Now, this won't be a problem if you're in first person. And it won't be a problem if most of your colliders are correct, because this is essentially what it's going off of. It will hit the collider, see which direction it's going in, and if it hits something with, let's say, a convex collider, you'll get mixed results one way or another. You can also adjust the speed by going into the player's, well, where is it? Over here? Nope. Yes, when you set the main speed, you'll probably also want it to say move. Jesus. Maybe this is why. So you'll times this vector by most likely time dot delta time. Now, you would only really do this if you're not creating a server. If you're creating a server, you can fix delta time is more for physics. Nope, not main controller. But generally, delta time smooths things out to a good enough length. Then we can also come down here and say private void change states. Come down here and say if input dot get key down, because we don't want to get all the keys. This one we're only going to be using one type of key, unless you're using multiple keys. I would suggest using one. So get key down, we'll come back over here, or main controller dot get variables dot get key list, and then from here we can go back into our key list and say, okay, the next key in our thing will be crouching. Why not? Which means when we have to go back in, dot crouching. The get down will only get the instance that, or when the key is gotten down the first frame that it's down. Anything afterwards will never return true. So you can go to main controller dot get variables dot change, or let's see, current state. We don't want to just get the current state, we also want to update it. And unfortunately, since we made this private in the player controller, you won't actually be able to update anything directly, that is. So you have to come in here and say, okay, well, I want to do public void change state keylist state, state, and then we'll do current state equals state. I was wrong. Player states. Now we can come back into here and say dot change state. Player states dot, and if you're crouching, or you can probably say at this point, or if main controller dot get variables dot get current state equals crouch. This is one way to handle if you don't want your players to be crouching midair, or if you don't want them to like crouch in the water or do something scary or game breaking. It's pretty good. However, if you don't necessarily care, then you can just see what the current, or you can say, oh, if they're standing, then you crouch, but if it's anything else, just make them crouch. Stand. such as if main controller dot get variables dot current state equals player state dot crouch. Now we sort of have a functioning character controller. It can walk in every direction. We'll just need to add another key code. Oops, don't want for. For the sake of things, I'm going to create this as an X because I like X as a crouch. I'm a little suspicious of this, mainly because if you see right here, those are zeros. Probably because I wasn't setting them right. Yeah, definitely not setting them right. Alright. The next challenge that we're going to do, I'm actually not entirely sure. Let's say I want you to connect the camera to the player. Yeah, that seems about good. Because that's very essential. So that's what we'll be doing next time, is connecting the camera to the player and being able to look around. Alright, thank you all for watching, and I hope to see you all next time. See you later, Code Monkeys.